We're going to start our discussion of methods for solving equations with what's arguably one of the simplest equations around, right? It's this one that we have here. It's called a linear equation. While these may seem very straightforward, you should get the hang of them pretty quickly with some practice. They're nevertheless very important. A lot of the more complex equations that we're going to look at as we go along here, the methods for solving them are all some variation on do some stuff until it turns into a linear equation, then solve it using the methods that we're talking about here. Right? So a lot of things we're going to do going forward are going to boil down to these really relatively straightforward things that we're going to talk about here for linear equations. And a linear equation is any one that can be made to look like this one. So the key things that we're looking for, there's no variables in the denominator. There are no exponents on the variable. There's no weird square roots or trig functions or logarithms, any of that kind of strange stuff, right? It's just x to a power plus some numbers, right? And we're not really going to be focused on what a linear equation looks like and identifying them. We're interested in solving them. And there's a procedure for doing that. Now, I know this looks kind of long and messy, and a little bit it is, but you'll find as we go through this and you practice doing these kinds of equations, solving these kinds of equations, this process very quickly becomes second nature, right? So throughout all of your study of mathematics, no matter how far you go, practice is really going to be an essential element. Okay, so another thing that's kind of useful to keep in mind here, you're not always going to have to do all of these steps. Right? Quite often we're going to be able to skip some of them. For example, the first one says eliminate any fractions or decimals. Well, if your equation doesn't have fractions or decimals, you're home free. Right? You can skip that step, move on to the next one. Right? So it's not going to be unusual for us to actually shorten this by several steps depending on the specific equation that we're looking at. So let's do that. Right? Let's look at some examples here. So say we want to solve this thing. Again, very basic little equation. And we are going to get to skip some steps here. There's no fractions or decimals, so we can check off step number one. There's no parentheses, so we can check off step number two. And if you look just at the two sides individually, there aren't any like terms. Right? So we're actually going to skip like the first several steps here. So the first step we are going to do is we're going to have to get all of the numbers, by number I mean the parts that don't have variables, over onto one side. So here's what I'm going to do. Right, the first actual math step here. I'm going to subtract 2 from both sides. Okay, so on the left-hand side, 2 minus 2, that's 0. Excellent. Those numbers went away. The left side, all that's left is 3x plus 0, and that's just 3x. And that equals 5. All right, one more step. Divide both sides by 3. And we get x equals 5 thirds. And that's where I'm going to stop. Right? Unless the directions to the question give you some specific reason to go further, stop here. 5 thirds is a perfectly good answer to this question. Okay, nothing wrong with fractions. And in fact, there are negatives to trying to go further. Every step, I tell my students in my ground classes and my online classes, every step you take is another opportunity to make a silly mistake. Right? It's 5 divided by 3. If you say this is 2 2/3, well, that's wrong. If you want to do this as a misfraction, it would be 1 2/3. But if you took that step when you didn't need to, and you got it wrong, I can't give you full credit anymore because your final answer isn't right, where it would have been if you had just stopped here. Right, another error you can make at this point is I'll see students do this sometimes. They'll say this equals 1.667. Well, that's also not true. That is, those two, that fraction and that decimal are not exactly equal to each other. That 5 thirds is actually a repeating decimal. And as soon as I stopped out there at the third decimal point and rounded, my answer became no longer the exact answer. And in math, quite often we're looking for exact answers. Right? So, unless there's something specific going on in the question that leads you to believe your answer needs to be in a decimal format, like I said, give your answer to two decimal places, for example, stop with the fraction. Right? Nothing wrong with 5 thirds as an answer here. All right, so let's try another one. This one has a little more going on. I've got parentheses to deal with now. All right, so I'm gonna no fractions or decimals, right? So we can skip step 1. But we do have to do step 2. We have to get rid of these parentheses, and to do that, I'm going to distribute this -2, this -2, into the parentheses, and I'm going to be super careful about the negative signs as I do that. All right, -2 times x, I shouldn't say minus, -2 times x is -2x, and -2 times -4, that's +8, plus x equals 3x minus 5. Good. Now, this time we also have some like terms. This -2x and this x can be combined together. They become -x plus 8 equals 3x minus 5. Now it's looking a lot like the last one did. Now I'm going to do the numbers. So I'll subtract 8 from both sides. We get -x equals 3x minus 13. And I'll subtract 3x. Again, from both sides. They cancel over here. That's 0. Minus 4x equals -13. And then divide both sides by -4. X equals +13 fourths. The two negative signs canceled each other. And there's our answer. Again, perfectly good answer to that fraction. Stop there. You're done. All right, actually, you're not done. All right, there was one more step that often gets kind of politely skipped over. The step that says check your result. And that is an important step, and I'll tell you, if I was doing this in a real-world situation, if I'm solving, doing some kind of calculations in a professional or a business setting, yeah, I am absolutely going to go back and check my work, because I don't want to hand the wrong numbers off to the VP of Finance or whatever, all because I didn't take 30 seconds to check my work, right? Absolutely, you should do that. Now, in a classroom setting, yeah, okay, we often skip over that. And yeah, that's okay. But look, just a little practical advice. If I tell my students, if you're taking a test, right, I would not check my work on tests. Okay, seems kind of strange to say, right? But I would not. I would go through and answer every question so that I get something on the page for every one. So even if I got it wrong, I'm setting myself up, trying to make sure I get at least some partial credit for every answer. Then, with the time I have left, after I've answered every one, that's when I would go back and start checking my work, right, and making sure every answer is correct. And again, making any fixes that I need to. Right, now, there is one other thing I want to point out about these, right? Let's go back to this step here. -x plus 8 equals 3x minus 5. Let's say I had done this instead. Let's say I had added 5 to both sides. Then my equation becomes -x plus 13 equals 3x. Now I'll add x to both sides, and again they cancel over here on the left. 13 equals 4x. Divide both sides by 4. And look, we ended up in the same place. We ended up with 13 fourths as the numeric part. But please don't leave this as your final answer. Right? We never write it this way when we're doing something like this, like solving equations. We always put the variable first. We would always say x equals 13 fourths. And I would not mark it wrong if a student gave this as their answer. I'd probably put a little note saying don't forget to turn around and put the x first. Because, yeah, technically that's correct. But just stylistically, we always put the variable first. And to see why, think of it from an English perspective, right? Think of it, you're trying to answer the question to someone who's asked this. In English, you would say x is 13 fourths. It would be very strange in English to say 13 fourths is x. Yeah, so the version of the answer, the format of the answer that we go with is the one that matches the way we would say this in an English sentence. All right, so that's the basics of solving a linear equation. You may have noticed I didn't do any examples that involved step number 1, clearing fractions and clearing decimals. That was actually by design. There's a couple of little pitfalls that you need to be aware of when you're doing those things in the process of solving an equation, which is why I left them out from here when we're just talking about the basics. In the next couple of lectures, I will do some examples of that, right? And I wanted to put them in their own lecture so we can really focus on those couple of little places where it's possible to accidentally go off track. All right, but before we do that, in the very next lecture, we're going to look at 2 special cases that can come up when you're solving these equations, and how to identify them, and how to phrase the correct answer when you have an equation that ends up being in one of those forms.